Let's take a look at the second question here, the Fisher effect. Fisher effect actually study the movement of the interest rate if there's a change in the expected inflation rate. So there are two cases here. First, expected inflation rate increases. The second case, expected inflation rate decreases. Let's focus on the first one. If expected inflation rate increases, what happened to the interest rate? And we know expected inflation rate can be written out as a pi e. E means expected. So if expected inflation rate goes up, how could this affect bonds market? Does this affect the bond demand or the supply? So we have to recall the factors that affect the bond demand and the supply. And we know one of the equation, Fisher equation, is very important. The real interest rate R equal nominal interest rate I subtract the expected inflation rate. So expected inflation rate up. If nominal interest rate remain the same, I remain the same, real interest rate will go down. Real interest rate represent the real return to the investors. If you as investors see the real return on the bonds goes down, are you going to buy more bond or less? You probably will buy less bond, so which means R goes down, real returns down, bond demand will go down. But could the expected inflation rate affect the supply side of the bond? Yes, because the borrower or company also look at the real interest rate to make decision. If real interest rate goes down, and we know the cost of the borrowing money down as well. So if cost of the borrowing down, if you are CFO of the company, you see the cost of the borrowing goes down, are you going to issue more bonds or less bonds? You probably want to take advantage of the cheaper money. You are going to issue more bonds because the cost reduce. So bond supply will up. So you can see here, expected inflation rate change, it actually can affect both bond demand and the supply. And we know if the bond demand down means bond demand curve shift to the left. And the bond supply up means bond supply curve shift to right. So let's take a look at the graph. Again, you can see because of both of the bond demand and the supply shift, they could exist a couple of the scenario. The first one, so now you should be very familiar with this. Price of the bond, quantity of the bond, supply and the demand. The initial bond price P0 and initial bond quantity Q0. We know the bond demand curve will shift to the left, but we don't know how much the bond demand curve will shift. So let's assume bond demand curve shift to the left a lot. So this is a D prime. You can see the size of the shift is big. And the supply curve shift to the right. So here assume supply curve only shift a little bit. So now we can find out the new equilibrium point using the D prime and S prime. We can find out is here. So that's the new equilibrium price, new equilibrium quantity. So our model indicate, in this case, the price of bond go down, so which means interest rate will go up because the inverse relationship. But what about if the bond supply curve shift more like the bond demand curve? We also need to use a graph to analyze. Let's assume again this is an initial equilibrium point. So if the bond demand curve only shift to the left a little bit, but the bond supply curve shift to the right a lot, what will be the new equilibrium point? That will be here. So again, in this case, you see the price of the bond drop, and the interest rate will go up. Again, because of the inverse relationship. So now we actually can make conclusion here. No matter how big the supply or demand curve shift, no matter what kind of the size they shift compared to each other, we use the A and B, we find out the price of the bond always increase in both cases. So which means interest rate of the bond in both cases, yeah, look at here, will increase. So now we actually can make conclusion of the Fisher effect. Fisher effect indicate if initially expected inflation rate up, and we can find out the interest rate I will go up as well. So that's what we call the Fisher effect. Expected inflation rate and the interest rate, nominal interest rate here, I, they move together. So next time if someone asks you what Fisher effect, you should be able to use this model to explain. Yeah, of course, you can do by yourself. If pi e reduce, what happened to the interest rate? It will go up or go down. I will leave you this question to you. You can practice by yourself to find out what happened to the interest rate I here.